Okay, what we want to do is to go over these problems, angle relationships. So we're going to review some stuff to do with angles, like linear pairs, vertical angles, and stuff like that. So let's look at these first two here. It says find each lettered angle measure without using a protractor. So we basically have these two angles just marked as congruent to each other. This is 112 degrees. By vertical angles, this has to be 112 degrees. And then because this is marked congruent, this has to be 112 degrees. By vertical angles, B has to be 112 degrees. These two angles B and C, or A and B, together make a linear pair, which means they add up to 180 degrees. So 68 degrees makes 180, and then by vertical angles, 68 degrees can jump across, or you can do the linear pair that way. So that's how we would do that one. For number two, all these together have to add up to 180 degrees. So we have 15 and 38. That gives 53. 180 take away 53 is 117. All right, is 127. It's 127. So A must be 127 because all together these have to be 180 degrees. Okay, let's look at the next ones. Okay, here, all the way around in the circle, we're going to have 360. Halfway of a circle is going to be 180. These are marked as equal to each other. Vertical angles lets me jump. Now, vertical angles are angles that share a common side, opposite vertexes, opposite of the vertex. D is going to be a 70. Looking at this arc right here, these all together have to be 180 degrees. We've got 110 with two equal angles. So 180 take away 110 is 70. 70 divided by 2, since we have two equal angles, is 35. So each one of these is going to be 35. Let's see what we can do with that. By vertical angles, B and 40 are a pair of vertical angles, so B must be a 40. If this is a 35 right here, by vertical angles, C has to be a 35. And that leaves us with angle A. A is a vertical angle. A must be a 35. And we've completely solved that one. Over here, these two angles are marked as right angles, or this is a right angle. So these angles are complementary. This must be 24 degrees. All together, these have to be 180. So we have 90 and 42 is 132. This must be 48 degrees. Okay, here, let's see. These all have to be 180. So A is going to be at 90 by vertical angles, or linear pair. B is going to be a 90. 132 and D make 180 because they're a linear pair. So this is going to be 48 degrees for D. 90 plus 48 is 138. 180 take away 138 is going to be 42. So C must be 42 degrees. That's how we would do that one. Leaves us with E. By vertical angles, E must be 132, since they're on opposite sides of the X. Over here, these angles have to add up to 90. That means A must be a 20. This 70 is a vertical angle with D, so D must be a 70. Altogether, D and E have to be 180. E must be 120. Let's see what else we got. Together, let's see, vertical angles, these must be 120 degrees. Well, that's going to help with that. If this is a 20 and this is a right angle here, this must be a 70. Okay, so that gives us our right angle there. And by vertical angles now, if we look at the opposite sides here, these must add up to 120. So we got 90 and 30 makes 120, since this is a vertical angle to this. So that's how we can get that that's got to be a 30. Moving on, linear pair, this has to be a 70 because it has to make 180. This is going to be 100 down here. This is a 25. Now, vertical angles lets me know that C has to be a 25. Altogether, 100 and these two need to make 180. We have 125 given to us. This must be a 55. And we got those. Okay. Over here, two congruent angles that make a linear pair. Each one of these must be a right angle. Each one of those is 90 degrees. Always, sometimes, nevers. The sum of the measures of two acute angles equals a measure of an obtuse angle. Obtuse means greater than 90 degrees for obtuse. I can think of a situation where I can have, like, say, two 30s that are two acute angles. They're not going to be an obtuse angle. But I could think of two 60s that are going to be greater than 90 because that's going to be 120. That makes this a sometimes. Because sometimes it is, sometimes it isn't. Number 10, if these are vertical angles, so let me draw this. It's saying that XAY and PAQ are vertical angles, then either XA and P, XA and P, or XA and Q are collinear, and that's going to be true. That's going to be an always. The sum of the measures of two obtuse angles equals the measure of an obtuse angle. If we add 220s together, we're going to come out with a 240. An obtuse needs to be in between 180 and 90, but not including 180 and 90. There could be two obtuse angles. Well, I mean, let's see, like a 91 and a 91 is going to be too much. So this is going to be a never for this one. The difference between the measures of the supplement and the complement of an angle is 90 degrees. So let's look at an example. Let's say we have a 60. The supplement of that angle is going to be 120. The complement of that angle is going to be 30, and that does come out to be 90. So I'm thinking this might be an always, but at least it's a sometimes. Okay, let me pause this. Let's look at the next one of these. 1314. If two angles form a linear pair, then they are complementary. Now, to form a linear pair, these angles need to add up to 180 degrees. And that 90 goes with complementary. So this is going to be a never. If this is supplementary, then it would be always. If a statement is true, then its converse is true. Not necessarily. That's how we actually test. Meaning, does fill in each blank to make a true statement. If one angle of a linear pair is obtuse, that means one angle adds up to 180 degrees. The other one has to be acute. Because if this is going to be bigger than 90 and they're a linear pair, they need 180, like 120 is an example. This is going to be a 60. It's going to be an acute angle. 16, if A is congruent to B and the supplement of A is 22, or supplement of B is 22. So if A is congruent to B and the supplement 180 take away 22 is going to be the measure, that's going to be 158 degrees for B. Then the measure of angle A must also be 158 degrees. This actually goes with B, since they're congruent to each other. If P is a right angle and P and Q form a linear pair, so if P is a right angle and P and Q make a linear pair, then we can see that Q also must be a right angle. If this is a 90, this has to be a 90 to make the 180. So the measure of Q is going to be 90. If S and T are complementary and T and U are supplementary, so if S and T are complementary, so let's draw S and T. Here's a pair of complementary angles. They make 90. And T and U are supplementary. So here's an example of T and U being supplementary and S and T being complementary. Then angle U is an obtuse angle. And switching the if and then parts of a statement changes an angle, changes a statement to its so we got if P then Q, if Q then P. Oh, that's the converse. Okay. So I don't know why I didn't get that. So switching the if and then parts around gives you the converse, which is kind of like what went on with the other one. Okay.